Okay, Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera. Alright class, so in this video, I want to show you how to solve problems involving calculating equilibrium constant. Okay, macam mana kita nak kira equilibrium constant ataupun mana-mana pengiraan ataupun problems yang melibatkan equilibrium constant. Alright, so let's start. Okay, so now based on the question given, okay, kita baca dulu soalan. Alright. The following equilibrium process has been studied at 230 degrees Celsius. Alright, so you can see here, we have 2 mole of nitric oxide gas reacts with 1 mole of oxygen gas reversibly, forming ataupun produce 2 mole of nitrogen dioxide gas. In one experiment, the concentrations of the reacting species at equilibrium are found to be: the concentration of nitric oxide is 0.0542 molar, the concentration of oxygen gas is 0.127 molar, and the concentration of nitrogen dioxide gas is 15.5 molar. Calculate the equilibrium constant Kc of the reaction at this temperature. Okey kelas. Jadi saya nak terangkan sekali dalam pengiraan ini ataupun dalam menyelesaikan soalan ini. Okey, nilai Kc ataupun nilai equilibrium constant tidak akan berubah. Jadi at constant temperature, sekarang ni temperature yang diberikan adalah 230 degree Celsius. Okay, so biasanya bila soalan beri pada awak, dia akan mention temperature sebab temperature ada kaitan, it is related to Kc value. So the Kc that you are going to calculate adalah for temperature 230 degree Celsius. Okay, so make sure you have a balanced chemical equation dan pastikan kita kena tengok phase. Kita tengok pada balanced chemical equation ini adalah homogeneous equilibrium. Okay, all the reactants and products have the same phase. Okay, right. And then what are given to you? You have the concentrations of the reacting species at equilibrium. So, Kc ataupun equilibrium constant dikira berdasarkan equilibrium concentration. Maksudnya nak kira Kc, kita mesti ada concentration at equilibrium. So, dalam soalan ini, in this example, the concentration of each reacting species at equilibrium were given. Alright, okay, so now let's start to solve the problem. Okay class, so firstly from the balanced chemical equation, we have to write down the Kc expression first. Okay, kita tulis dulu Kc expression, and since the equilibrium given adalah homogeneous equilibrium, maksudnya fasanya semua sama, gas, maka kita akan ambil kira ke semua species. We are going to we cannot ignore the concentration of each species dalam equilibrium ini sebab dia adalah homogeneous equilibrium yang mana semuanya adalah fasa gas. Yang kita ignore adalah pure liquid ataupun pure solid, because we assume that the concentration of pure liquid and pure solid adalah constant. But in this case, dia adalah gas, memang tak boleh abaikan. Okay, so now write the Kc expression. So firstly, it is equals to concentration of nitrogen dioxide power of 2 divided by the concentration of the reactants. So we have 2 reactants. So hasil darab dua concentration reactant ini, concentration of nitric oxide power of 2 times the concentration of oxygen gas. So this is the Kc expression. Wajib tulis. It is a must. Right? Okay, so since we already have the concentration at equilibrium, so saya tulis semula kat sini at equilibrium what we have. Okay, at equilibrium we have the concentration of nitric oxide, the reactant is 0.0542 molar, and then the concentration of oxygen gas, which is also the reactant, 0.127 127 molar, and the concentration of nitrogen dioxide, which is the product, is 15.5 molar. So we already have the concentration at equilibrium. Jadi kita boleh substitute all these information, all these data into the Kc expression. Okay, so now Kc is equal to substitute. Okay, first tengok kat sini, ini adalah concentration of the product power of 2. Power of 2 datang daripada balance chemical equation. Alright? Okay. Baik, jadi kat sini kita akan gantikan dengan nilainya 15.5 power of 2 divide by, okay, look at the concentration of nitric oxide, one of the reactant. Okay, the value is 0.0542 molar. Power of 2 times concentration of oxygen gas, which is 0.127 molar. So you don't have to substitute the data including its unit S, sebab unit Kc tidak memberi apa-apa makna. So solve by using your calculator, scientific calculator, mathematically. So suppose you get around 6.44 times 10 to the power of 5. So tidak ada unit sebab unit Kc ataupun equilibrium constant tidak membawa apa-apa maksud. So apa yang letak unit? It is dimensionless ataupun meaningless. Tak ada maksud, tak ada makna apa pun. Okay, so settle with the first example. Okay, so now let's move to the second example. Okay. Right, so this is the second example. Okay, let's analyzing the question. Okay, so the equilibrium constant Kp for the decomposition of phosphorus pentachloride PCl5 to phosphorus trichloride PCl3 and molecular chlorine Cl2 is found to be 1.05 at 250 degrees Celsius. And this is the balanced chemical equation. So you can see the decomposition of PCl5 phosphorus pentachloride undergoes reversibly. Okay, if the equilibrium partial pressures of PCl5 and PCl3 are 0.875 atm and 0.463 atm respectively, what is the equilibrium partial pressure of chlorine at 250 degrees Celsius? Okay, kita analyze soalan, analyzing the question. Okay, we have the Kp here. Kp value for the reaction that occurs at 250 degrees Celsius, which is 1.05. So we have the Kp. Okay, saya tulis dululah kat sini. Kp 1.05. Okay, and then kita sudah ada equilibrium partial pressures for PCl5 and PCl3. So yang kita tak tahu adalah partial pressure at equilibrium for molecular chlorine Cl2. Okay, so kita cuba organize maklumat tersebut, kita susun balik. Okay kelas, so kita tulis semula, organize semula maklumat tadi. Alright, so we have Kp value given, which is 1.05, right? And then we have the at equilibrium. At equilibrium, we have the partial pressure of phosphorus pentachloride, which is 0.875 atm. The partial pressure of phosphorus trichloride, which is 0.463 0.463 atm. The unknown partial pressures of the reacting species goes to the partial pressure of chlorine gas. So yang ini yang kita tak tahu. Okay, so now write down the Kp expression. Kp which is equals to the partial pressure of phosphorus trichloride times the partial pressure of chlorine gas, okay, divided by the partial pressure of phosphorus pentachloride. Okay, so now substitute all the values in the Kp expression. So we have here 0.463 atm, alright, times the unknown concentration, the partial pressure of chlorine, divided by the partial pressure of PCl5, which is 0.875. Supposed to be we will get 1.05, but you are going to solve the partial pressure of chlorine. So by using your calculator, mathematical operation, so suppose you will get the final answer is 1.98 atm, including the unit. The unit is compulsory because we are calculating the partial pressure of chlorine, not Kp. Kita kira partial pressure sekarang, bukannya Kp. Jadi mesti ada unit. Okay, so this is the final answer. Alright, so settle with example number 2. Okay, so now let's move to the last example in this video. Okay. Alright, so let's read and understand the question together. Methanol is manufactured industrially by the reaction given. The equilibrium constant Kc for the reaction is 10.5 atm at 222 degrees Celsius. Calculate the equilibrium constants, okay, Kp at this temperature. Okay, baiklah. Sekarang kita sudah ada balance chemical equation, dan daripada balance chemical equation given, kita nampak it is clear that this is a homogeneous equation, that all the reacting species have the same phase, iaitu gas. Okay, alright. So given to you the Kc value at this temperature, and you are going to determine the Kp. Itu sahaja yang kita ada. Okay, so actually how to solve the problems? Okay, so kita tulis semula apa yang kita ada. We have Kc 10.5. Okay, and this Kc value adalah untuk reaction yang berlaku pada suhu 220 degree Celsius. So sekarang kita nak cari Kp. Kp value yang kita tak tahu. So we don't have any information about partial pressure of each reacting species ataupun concentration. Jadi tak mengapa, actually kita boleh selesaikan yang mana kita akan menggunakan perkaitan apa? Kita akan menggunakan perkaitan Kp equals to Kc times RT power of delta N. Okay, tengok formula ini betul-betul. Alright, tengok formula ni betul-betul, especially pada RT ni. Kurungan, bracket, RT, tutup kurungan, baru power dengan delta N. Okay, jadinya sekarang apa yang kita nak buat sebelum kita kira? Apa yang kita nak buat sebelum kita kira? Okay, of course, R adalah 0.08206. Temperature 222 degree Celsius. Kita akan gunakan R constant. So temperature must be converted into Kelvin. So kalau you convert, you akan dapat 493.15 Kelvin. Okay, what else? Okay, Kc memang kita ada, so you have to determine the delta N. Macam mana nak cari delta N? Delta N adalah mole of gaseous product minus the sum of mole of gaseous reactant. Tapi sekarang kat sini kita tengok adakah dia semuanya sama. Kita tengok adakah dia punya phases bagi all the reactant species, product and reactant sama. Itu yang tadi saya kata tengok pada balance equation. Sangat penting untuk kita baca balance equation ini ataupun fahamkan. So all the phases sama iaitu gas, maka kita akan kira delta N. So macam mana nak kira delta N kat sini? Okay, tengok mole of product dalam equation ada 1 metanol. So 1. Okay, tengok bahagian reactants in the balance chemical equation. Mole carbon dioxide tu 1, mole hydrogen gas 2. Jadi kat situ maksudnya 1 tambah 2. So 1 minus 3. So delta N is equals to negative 2. Okay. Itu cara kira delta N. Okay, so now let's continue to calculate the Kc. Alright, so from this equation, Kc kita nak kira Kp. We're going to calculate Kp. Okay, so Kp equals to Kc times RT power of negative 2. So substitute all the values. Kc is 10.5, right, times R gas constant 0.08206. Actually the unit of R is liter atm per mole per Kelvin. So kita nak cari Kp tak payah masukkan unit. Okay, ini pula kena hati-hati, ada kurungan. Tengok kat sini, ini yang kena berhati-hati. Times 493.15 power of negative, tutup kurungan power of negative 2. Selesaikan secara matematik. Please be careful when you solve the mathematical question ataupun calculation. Okay, supposed to be the final answer is 6.41 times 10 to the power of negative 3.